9.5 is going to ask you to solve radical equations. So by that they mean an equation that involves a radical expression, and you're going to have a variable underneath the radical. So an example of something like that would be problem number 18. Square root of 5x minus 6 equals 2. There's going to be something a little bit unique about solving these types of equations. There's going to be a little bit more work you're going to have to do when you're all finished. And I'll kind of hint at that work in a second. But what do you think I'm going to do first? If you're given an equation like this, you need to get x by itself. What can we do? How are we going to get x by itself? Any suggestions? All right, take out the square root. What's going to take out the square root? What operation do I have to do? Emily? Yeah, we're going to square each side, okay? Because as we've seen before, squaring and square roots are opposite operations. They cancel each other out. So if I square both sides, on the right-hand side, I'll get a 4. What am I going to get on the left-hand side? Yeah, 5x minus 6. So to finish solving then is not so bad, because now I can add 6 to both sides and then divide by 5. So add 6 to both sides, 5x equals 10. So x equals 2. Nice. 5 times x, there we go. So not so bad. But there is one little extra step that you have to do here, and you have to check your answers. It's no longer an if you have time, or it's a good idea. You have to check your answers. So the question is why? What's unique about these? Well, suppose I had a equals 5. Don't even copy this down. Let me just kind of demonstrate to you why you have to check your answers here. What if I squared both sides of this equation? Well, I get a squared equals 25. Now let me solve this. And I'm going to solve it by factoring. I'm going to move the 25 to the left-hand side, and then I'm going to factor a plus 5 times a minus 5 equals 0. That's just the difference of squares. What are my two solutions to this quadratic equation? A equal negative 5 and positive 5. But take a look at this very simple equation. Does a equal negative 5 fit in here? Does that make that true? No. Negative 5 does not equal 5. So that's an extraneous solution. You did your work right here. It's just that the number you came up with didn't solve the original problem. So sometimes you can accidentally introduce these extraneous solutions in the process of solving these things, so you have to check it. It's no longer, gee, this is a good idea. You have to check it. So let's check it. So if I put in a 2 here, I get the square root of 5 times 2 minus 6. Does that equal 2? Well, 10 minus 6, square root of 10 minus 6 is the square root of 4, and square root of 4 is 2. So it checks. But you have to make sure when you do these problems that it does check, that it works in the original problem. There will be probably 2 points on your test for showing me that you checked your work, regardless of anything else. You want to show me that you checked your work on those. Let's do a few more here. And what you're going to see after problem 20 is kind of an increase in the level of difficulty. There's going to be more and more things to do as you work your way through these problems. So let's see if we can't catch on to all these little tricks. But we'll start out kind of gently with problem number 20. Give you a chance to do the same thing that we did with the previous one. 6x plus 1 equals 5. I should say the square root of 6x plus 1 equals 5. Ready, set, go. Give that one a shot. Looking good from what I saw. So as with the last one, you're going to square both sides. When you square the left-hand side, you get 6x plus 1. Right-hand side gives me 25. Subtract 1 from both sides, and then divide by 6. We get x equal 4. But make sure you check your answer. So when we plug in the 4, does it work? Well, 6 times 4 is 24. 24 plus 1 is 25. And the square root of 25 is 5. So it checks. But like I said, checking your answer is just a part of the problem. It's something that I do want to see. Let's try another one. Problem number 24. Kind of hinted a minute ago that these are going to increase in difficulty, and we'll see that starting with problem number 24. So square root of 2a minus 3 plus 3. I just want to double check. I've got that equal to a. Is that right? All right, good. Equals a. So the first thing you have to do is get the radical by itself. Do not square this. Do not square both sides just yet, because on the left-hand side you get a really, really big mess. You don't want to do with it. So first thing I'll do is I'll subtract 3 from both sides to isolate the radical on the left-hand side. So I get a minus 3 on the right-hand side. Now I can square it. But there's going to be 2 key steps in solving this problem from here that you're going to have to pay attention to. So the first one is right here. And that is when we square both sides, squaring the left-hand side is no big deal. But what about squaring the right-hand side? What do I have to do to square the right-hand side? I have to FOIL this. You can't just square a squared minus 3 squared. It won't work that way. So on the left-hand side, I get 2a minus 3. On the right-hand side, let me write that as a minus 3 times a minus 3. We have to FOIL that all out. So on the right-hand side, I'll get a squared minus 3a minus 3a again plus 9. So first, outside, inside, last. Okay, looking better. What next on the right-hand side? Yeah, thanks, Rhonda. Add like terms. A squared minus 6a plus 9. 2a minus 3. But now what? Mackenzie, any ideas? All right. Got that. Well, because of the presence of that squared term, this is a quadratic equation. And there's a few ways we had to solve quadratic equations, but all of them relied on getting something on one side. What was it? 0. So we need to get 0 on one side. So let me move everything to the right-hand side. I'm moving things to the right-hand side because I've already got a positive a squared here. So I figured it would be easiest to do that. So I'll subtract 2a from both sides. And then I'll add 3 to both sides. So I get 0 equals a squared minus 8a plus 12. Okay. So this feels like the problem that never ends. Now what? Factor that. Good. So Gil, how would that factor? Perfect. Two things that multiply to positive 12 and add a negative 8. So a minus 6, a minus 2. Someone read off the solutions for me here. Norman, what are the 2 solutions I get here? 6 and 2. All done? No. You got to go back and check your answers. Make sure that they both work. So we'll start with a equals 6. Check a equals 6. Square root of 2 times a minus 3 plus 3 equals a. So when you're checking your answers, go back to the original problem. 2 times 6 minus 3 plus 3, does that equal 6? Well, find out in just a second. So 2 times 6 is 12, minus 3 is 9. Square root of 9 plus 3. Does the square root of 9 plus 3 equal 6? Yes. The square root of 9 is 3. So it checks. Let's try a equal 2. So square root of 2 times 2 minus 3 plus 3, does that equal 2? So square root of 1 plus 3, does that equal 2? Yes.
I'm just curious, how did you get, like, it says a minus 3 and a minus 2. How would a equal positive 6 and positive 2?
So you're talking from here?
Yeah, yeah.
Okay, so it's...
No, on the solution. Yeah, for the solution.
Oh, down to here?
Yeah.
Okay, so what happens is that you've got this times this equals 0. So if you're multiplying two things to get 0, one of them has to be 0. The only way you get 0 as the result of a multiplication is it has to be 0. So that means either a minus 6 equals 0 or a minus 2 equals 0. So when a minus 6 equals 0, when a equals 6, or a equals 2, respectively. So the shortcut when you get down to this point, assuming you have something simple like this, is just to change the sign. So if I had a plus 6, this would be a minus 6. All right. How about a equal 2? Did a equal 2 work out? No. So a equal 2 is an extraneous solution. You have to cancel that one out. I'll be looking at... Now, you don't have to write extraneous. I know it's a big word. That's fine. Extraneous. But a equals 2 is an extraneous solution. The only solution that works is a equals 6. And that's it. So you can see it's important that you got to go back and check your answers. It's not just a good idea. 2 doesn't work. Yeah. So there's like several different possibilities. They could both work. You could have one work, or occasionally neither would work. So even for myself, I can't tell just by looking at the problem what's going to happen when I check the answers. You just have to plug it back into the original problem and see. Yes? If you just cross it out like this, when it doesn't check, that's fine. You don't have to get really elaborate. I am happy when I see the work here. But some of you are going to do it on a calculator. That's fine. But I would like you to show me that you're checking your work somehow or another. All right. It doesn't have to be. You don't have to show me as much detail as I put here, but something. Anything else on problem number 24? Why don't you try problem number 28? Unless you want me to do one more first. Want me to do one more first? All right. Let me do one more first. Problem number 26. So negative x plus 2. Excuse me. Square root of negative x plus 2 again equals x. So what would be a good first step on this one? Subtract 2. Good. You need to get that radical by itself. So, okay, we'll subtract 2. Square root of negative x plus 2 equals x minus 2. Sierra, what could I do next? What should I do next? Maybe one of your classmates can help out. Yeah, square both sides. So squaring the square root is going to get rid of that radical. And it's going to free things up so I can move the x around and finish solving. So, thanks, Rhonda. So I'll square both sides. On the left-hand side, I get x plus 2. Colin, what am I going to have to do to get the right-hand side? Good, you have to FOIL this. So it's x minus 2 times x minus 2. I guarantee you, this is the most frequent place that people are going to stumble on this problem, is that they're going to want to say, oh, well, that's x squared plus 4. Well, not quite. You have to FOIL that out. And when you FOIL it out, you're going to get x squared minus 2x minus 2x again plus 4. Oops. So the like terms that you get here combine, and I get x squared minus 2x. Minus 2x again is a minus 4x plus 4. Yay. So be careful with this one step here. That's going to be the first gotcha. The second place that people are going to stumble is remembering to check their answers. But we got to get those first. So to finish solving this, what should I do? Add x to both sides, and then what else? Subtract 2. So I get 0 equals x squared minus 3x plus 2. Should I pull out the quadratic formula here? You could. It's kind of like burning down a house to roast a pig, but, you know, you could. Abdul Aziz, how does this one factor? Good, x minus 2 and x minus 1. Bailey, can you tell me what the values of x would be here?
It would be x equals 2 and y equals 1.
Perfect. So just change the signs there. X equal 2 and x equal 1. Does that work for us? I got to check them. So let's start by checking x equal 2. So check x equal 2. So let's plug in a 2 into both of these. So it's really the negative of 2 plus 2 plus 2 again outside the root. Does that equal to 2? Square root of 0 plus 2 equals 2. Yeah, that works. So the first one checks. Why don't you try the other one? And again, let me stress, even for myself, I can't tell ahead of time if we're going to get one, none, or both to check. You just have to go through all the motions. Kennedy, did it check? Good. Square root of 1 plus 2 is 3, and that doesn't equal 1. So this is an extraneous solution. It's enough just to cross it out there for me. But I need to see that the solution is crossed out. That way I know that you've checked it, regardless of whether or not you've shown me the work or you did it on your calculator. All right, I think you should try one yourselves. And going to be problem number 28. I think I might make a small change on problem number 28. And that is, instead of a t, we're going to write an x. Other than that, we're going to keep it the same. So, problem 28. Square root of x plus 3 minus x equals 1. Okay. This one's yours. Good luck. All right, I'm going to slowly do it up here. You can keep working for yourselves. I'll probably catch up to you a little bit, but keep working by yourself if you'd like. Okay, so The first thing you need to do is you need to get this radical term by itself on one side. So I move the x to the other side. Square both sides. That'll clear out the radical. And then that allows you to move the 3 or in the x wherever you want or need. So in this case, when we square both sides, you have to be careful about squaring the right-hand side. You have to FOIL out that binomial. X times x is x squared plus x again plus 1. Or better yet, x squared plus 2x plus 1. Subtract x and subtract 3 from both sides. I get 0 equals x squared plus x minus 2. Always look to see if something factors. This one factors. I know I need an x and an x, a plus and a minus. And the last two numbers have to multiply to 2, so there's not too much choice there, right? There's 1 and 2. It's just a matter of which one's positive, which one's negative. Yeah, the bigger one has to be positive, so 2 is positive. That gives me 2 possible solutions. Question? All right, so I've got x plus 2 times x minus 1 equals 0. What are my 2 solutions here? -2 and 1 respectively. Let's go back and double check our work now. Not double check our work, but double check our answers. We need to make sure that they both work, or maybe neither work, or maybe only one of them works. We'll find out. So let's check the first one. So I'm going to plug in -2 here. So -2 plus 3 minus -2, does that equal 1? I'm thinking it's not going to work out. So I'll get the square root of 1 minus -2 is really the square root of 1 plus 2. And that doesn't equal 1. So I'll throw that one out. That one's extraneous. Let's take a look at the other one. So let's check x equal 1. So if I check x equal 1, well, let's see what happens. 1 plus 3 is 4. Square root of 4 is 2. 2 minus 1 is 1. So x equal 1 actually checks, whereas x equal -2 didn't check. No, there's not. I don't know as though I have an example of one where they both work picked out, but you know, it depends on the problem. I've seen one, none, and both. So, you know, anything can happen. Correct. Yep. So let's look at problem number 32, unless there's some more comments or thoughts on 28. What I'm hoping is that we're going to finish the material for this chapter, for this exam early, and then we can spend a little time on review. So, problem 32. Square root of 3x plus 5 equals 2. First step, what should we do? All right, subtract 5 from both sides. Square root of 3x equals -3. Cool? Sidra, what from there?
And then you square.
There you go. Thank you. Square both sides. Kyle, when we square both sides, what equation pops out? 3x equals 9. Good. So x equals 3. All done? Got to check it. So Square root of 3 times 3 plus 5, does that equal 2? Notice that I always go back to the original problem to check my answers. So square root of 9 plus 5, does that equal 2? No. So, by request, there's one with no solution. There's just no solution on this one, period. Let's try a couple more, couple different ones. Kind of mix things up a little bit. Problem number 36. Cube root of 12m plus 4 equals 4. What's an important difference between this one and our previous problems? It's a cube root, right? So what do you think that's going to mean in terms of how we approach solving this? Yeah, perfect. Thanks, ladies. You're going to cube both sides instead of square both sides. So 12m plus 4, or the cube root of 12m plus 4, that gets cubed. 4 gets cubed. Can someone tell me what equation I get when I cube both sides here? Thank you. 12m plus 4 equals 64. You can subtract 4 from both sides. 12m equals 60. So m equals 5. If you check it, we get the cube root of 64, and that does equal 4. So it checks. Let's try problem number 48. Square root of m plus 4 equals the square root of 2m minus 5. Again, a little bit different. What do you suppose we're going to do to solve this one? Square both sides. All right. So when I square both sides, Mitchell, what equation do I get, please? Spot on. All right. I think he was ready for that one. All right. So m plus 4 equals 2m plus 5. Since 2 is bigger than 1, I'll move the m's to the right-hand side by subtracting m. And then, being uber efficient, let's also add 5 to both sides. What equation do I get? Jamie? Yeah. 9 equals m. Wow.
That was easy.
Yeah. That was... All right, we still have to check our answer. Let's see here. M plus 4 is 13, so I get the square root of 13 on the left-hand side. 2 times 9 is 18, minus 5 is 13. So I get the square root of 13 equals the square root of 13. It checks. So it works on both sides. So kind of a nice friendly one there as we're winding down on this section. You do have to be a little bit more careful when we work with problems like 52. Square root of 12x plus 24 equals 6 times the square root of x. So 12x plus 24 Square both sides. The left-hand side is pretty simple. It's 12x plus 24. But how about the right-hand side? What do we get when we square the right-hand side? 36x. You have to square each of these individually. So 6 squared is 36. Square root of x squared is just x. So subtract 12x from both sides. And isn't this special? 24x equals 24. Anyone want to take out their calculator and tell me what x equals? 1. X equal 1. Does it work? Well, what's 6 times 1? 6. Square root of 1 is 1 times 6 is 6. So on the right hand side I get 6. On the left hand side I get the square root of 12 plus 24 is 36. Square root of 36 is 6. So that one checks. And I'm sorry if I'm kind of rushing through the checks on these a little bit. If you'd like, I could actually write them out. Kind of a fun one to do is problem number 105. I think we might change it a little bit. Let's change it up to kind of match the Detroit area. Says a curved road will accommodate traffic traveling s miles an hour if the radius of the curve is r feet. According to this formula, s equals 3r. If engineers expect 40 mile per hour traffic, what is the radius that they should specify? So let me zoom out just a little bit. Oops, other way. So you can see here. So basically what the engineers are going to do is figure out, well, how wide of a turn this should be in order to accommodate traffic of a certain dimension. So let's think about what that radius would be. Well, we don't know, but we do know how fast the traffic is going to flow. So it's this formula S equals 3 square roots of R. Let's write that down to get started. So 105 S equals 3 square roots of R. Now, for myself, when I think of this problem, I imagine the exit ramp from 75 southbound to 696. And people do not travel 40 miles an hour. More like 70. So let's put in, I don't know, 90? Want to do 90? All right, 90 will work out pretty good. So let's say that S equals 90. That's in miles per hour. You know what? I wrote a 5 here. Why did I write a 5? This should be S equals 3 square roots of R. It's because my colleague was coming over here. He put something on my outside window. I don't know what kind of joke he left here, but he's messing with me. All right. S is 90, so that gives me 90 equals 3 square roots of R. There's a couple ways that we can do this one. You could square both sides and then solve for R, but I think I might take a different approach, especially since you gave us such a nice, easy, friendly number. What else could you do here, do you think, to get started? Good, divide by 3. So let's divide both sides by 3. So we get 30 equals the square root of R. What am I going to do to solve here? Square both sides, right? So I get 30 squared is the square root of R squared. And you look at the left-hand side board and you realize that, okay, I stopped at 20. So you take out your calculator and find that the radius of the turn should be 900 feet. I imagine they're going to be doing this kind of calculation up on I-75 near South Boulevard and stuff like that. If you've driven by there, they plan to do some major renovation up there. Whew. All right. How are we looking on problem 105. Should we do one that works out with less even numbers? Yeah, the difference is that 40 is not evenly divisible by 3. That's why I was so happy when she said 90. I could. I could. Let's do one last one, problem number 106. Kind of a cool one. We'll do a similar calculation in section 9.6. So says the taller a lookout tower, the farther an observer can see. The distance, called the horizon distance measured in miles, is related to the height of the observer by the formula d equals 1.22 times the square root of h. How tall must a lookout tower be to see the edge of a forest 25 miles away? So what's that 25 miles refer to? Where am I going to put that into my formula? D. So the equation that I need to solve is d equals 1.22 times the square root of h. So for 106, 25 equals 1.22 times the square root of h. What I would suggest is that we divide both sides by 1.22. You get 25 divided by 1.22 equals the square root of h. And then solve it from there. Yes, sir.
Could you also do like 1.22 times the square root of h squared? 25 squared?
So alternatively, you could square both sides here and get 25 squared equals 1.22 square root of h squared. So that would be 625 equals, I don't know. Okay. Squared. So yeah, 1.4884. Oops, it'd be just times h now. And then divide 625 by 1.4884. And whatever that is, that's going to be your h. So that's one possibility. You're essentially getting the same thing here. Because when I square both sides here, I'm going to have to square the numerator and square the denominator. So square that. I'll get 625 divided by 1.4884. So whatever that turns out to be. So yeah, good question. They both work out the same way. As far as doing it on a calculator, I mean, we don't need to necessarily write out that. What we could do would be take 25 divided by 1.22, press the enter key, and then hit the square key. So just square it. So 400 and call it 20 feet. So it's pretty tall. I'm trying to think. How tall does a top fuel dragster take you in Cedar Point? Is it that high? Is it 400 feet? Maybe not. I'm not sure it's that tall. In any case, about 420 feet tall. Yes? Technically we should, but I guess I didn't. I neglected. You can. Let's see if we can make that work. So to check this answer, what I think I would do is I would take this answer and store it in my calculator, store it in X, and then try 1.22 times the square root of X and see what I get. 25. All right. But I'm not going to try and trick you on these. They'll check. All right. Good question. The correct answer from me would be, yeah, you should check it. But you know, that little fancy trick with your calculator is not something that I require of you. For homework, This is section 9.5. Try 15 through 35, 47 through 53, and then a couple bonus problems, 105 and 107. So I would look at these. These are the kinds that we just did. I would hasten to point out that we're skipping some pretty nasty problems. Let me just give you an example of one of them. Problem number 56. Square root of x minus 7 plus square root of x equals 7. The challenging thing about this one is that you've got two square roots to deal with, and you can't get them both by themselves at the same time. Now you can move the first one or the second one into the right hand side and get 7 minus the square root of x, and then I can square both sides. But when I square both sides, I'm not going to completely get rid of the radicals. I'll get x minus 7, and when I FOIL this out, 7 minus square root of x, I'll get 49 minus 7 square roots of x minus 7 square roots of x, again, plus square root of x squared. So, wow, the radicals didn't cancel out. I'm left with x minus 7 equals 49 minus 14 square roots of x plus x again. So, well, what do I do now? Now I subtract x from both sides and get negative 7 equals 49 minus 14x, or 14 square roots of x, like that, because the x is canceled out. Let me keep working with this. I'll subtract 49 from both sides because I want to get the square root of x term by itself. Is that a minus 7? Yeah, okay. So I'll get negative 56 equals negative 14 square roots of x. Then what? Then divide both sides by negative 14. And I get 4 equals the square root of x. Still not done. Square both sides. 16 equals x. And if you go way, way, way back into the beginning of the problem, that'll check. So the good news for you is I do not put these on the test. But occasionally I like to show you what I'm sparing you. All right, let's take a break here.